Okay. All righty. Now, so we have so the final will cover lessons 5.3 and 5.4, and then 6.1 and 6.3b. So just the last 4 lessons. Everything is since test 2, so it's not comprehensive. So what I'll do is I'm going to mark up this document with the notes I make when talking about these problems, and then I will post this in Canvas. So what it's asking for here is finding the absolute max and min on a given interval. So what you need to check are the endpoints, 0.7, 2, and 6, and also any critical values, in other words, points where a derivative is 0, within the that fall within this interval. So I need to set this up so I can modify it. Okay. So if I go ahead and take the derivative, so we get here from power rule, it'd be 24x squared minus 7 times the derivative of natural log of x cubed. But the log of x cubed can be written as 3 natural log of x. So if I write it this way, 3 natural log of x prime, so 3 ln of x is the same as ln of x cubed, then the derivative of this would be so derivative of ln of x is 1 over x. So you get 21 over x. Okay. So now that you have your derivative, we need to set it equals 0 and see where there are critical points. So we have 24x squared minus 21 over x is equal to 0. But that's the same as saying 24x squared is 21 over x. Then multiply both sides by x. And then, so we have x cubed over here, and then divide both sides by 24. So now we have x cubed is equal to 7 over 8. So 7/8. So then we would take the cube root of both sides, but that's the same as raising 7/8 to the 1/3 power, and that you'd have to work out on your calculator. And when you do round it to 2 decimal places, we get 0.96. Now that does fall within this interval. So the candidates for absolute max and min are x equals that critical point and the 2 endpoints. So going from left to right, it's these 3 points that you now have to substitute into the original function, and then the smallest value is the maximum, largest value is the minimum. So what happens when you do that? Okay, so then I have 8x cubed minus 7 times natural log of x cubed. Okay. So what we get is excuse me. So the left endpoint, you get 9.88 rounded to decimal places, and then 0.96 turns out to be slightly smaller, so 7.94. And then the last point, 6, that value is going to be a lot larger, and we get 1,690.37. So x equals 6 is where the absolute max happens. That's certainly the largest value. Smallest value happens at the critical point, 0.96. And this is how you have to enter your answers in Hawks when it's asking for absolute extremas. Notice it says write your answer in this form, the x value and the corresponding y value. So this is what you put in the minimum box. This is what you put in the maximum box. So any questions about what happened here? Okay. All right, here's another problem of the same type. So this function on this interval. Now, when you're taking natural log of you have a natural log of some function of x, and you're taking a derivative of that. So we're using this rule, derivative of ln of some function g of x. Well, the derivative of natural log is 1 over. So you have 1 over g of x. But then by the chain rule, you must take a derivative of whatever it is you're taking the log of, and multiply by that. So it's actually g prime divided by g. So that's the rule that you're using for a function like this. Whereas in the previous problem, you could write in such a way that you're just taking natural log of plain old x. So what that gives you is the derivative of what you're taking the log of. So that would be 20x minus 9. And then divided by a function you're taking a log of. So just repeating that denominator there. Okay. So then you would take this derivative and set that equal to 0. But, sorry, I need to move this. Okay. To see when this is equal to 0, you'd only look at the numerator. So we just, so something to keep in mind, whenever your derivative is a fraction, you want to see where it's equal to 0. Just look at numerator, 20x minus 9 is equal to 0. So x is 9 over 20. So that'd be 0.45. Now, here's a common mistake. You get a critical value and think, oh, okay, I'll just substitute that into a function along with these endpoints. Well, no, you don't. Not in this case, because this x value is not in the interval. So it will not be considered. Okay. So always check that before you actually consider it for absolute max or min. So the candidates are only the endpoints. So you would just substitute these into a function, and since you only have those two values, one of them is going to be the max and one of them is going to be the min. And we can see here that when you substitute these into a function, that 6.3 turns out to be where the min is, 18.1 is where the max is. Okay. Questions on this one? Now, next one. Okay. So now we have, well, not the whole problem stated here on this page. Here's our function that describes how much is sold in terms of how much is spent on advertising. So that's X thousands of dollars in advertising. So this function, okay, 380 plus 83. Okay, I need to repeat, pardon me, the function down here. Okay, 380 plus 83. Four plus 1.5x. Okay, find how much advertising, how many pieces of equipment are sold if 7,000 is spent on advertising. Now remember, X is in thousands of dollars, so you would just compute N equals 7. So you'd work out in your calculator, and this is what you would get for that. Now, step 2, rate of change in how many pieces sold at the same level of advertising. So rate of change, remember, that indicates derivative. And since N of X is the number of pieces of equipment sold, rate of change in that would be the derivative of that. So what you would fill in is N prime of 7. Now, as far as how you would get that, so N prime, you would get nothing from the 380. It's just a constant. So then you have 83 divided by this, because derivative of ln of this is 1 over that, 4 plus 1.5x. But then you have to multiply by the derivative of whatever you're taking a log of. That's the same thing that happened in the previous problem. So then we'd have 1.5 up here. So after cleaning up everything, you'd have 124.5 divided by 4 plus 1.5x. So then you would substitute x equals 7 into here, and then rounding to the nearest whole number, you would end up with 9. All right, here the only thing it's asking for is a derivative. And it's more convenient if we rewrite the function using the properties of logs. Because here we have natural log of x to the 4th, but that's the same as 4 times the natural log of x. So when you take a log of something raised to a power, that exponent can be pulled out, put down here. Then when you take a derivative, you get 34x just from a power rule, and then natural log of x its derivative would be 1 over x, thus the 4 over x that we see here in the answer. All right, here too, just taking a derivative, but even though we have a quotient in here, it's actually possible to take the derivative without using the quotient rule, using properties of logs. So I'm going to rewrite the function first before taking a derivative. So first, we're taking a log of something that's squared. So that exponent can be pulled out, just like in the previous problem. Okay. But then we can go further, because now that the 2's out of the way, we have a log of a quotient. The log of a quotient is the difference of the logs. So log of numerator minus log of denominator. Okay, so now we can use a rule that I showed you previously. Log of a function is the derivative over the function. So using this rule, what we get is y prime is equal to, we're going to have a 2 multiplying everything. So it'll be derivative of 5 plus 4x, which is just 4, over 5 plus 4x, minus derivative of this part. So that would be the derivative of its function inside. So that would be 40x minus 9 over 20x squared minus 9x. So then we can just distribute the 2 through everything. And this is where you can stop. Okay. I'm checking to see if I did any further simplification. Sometimes you can, but it's not necessary. Do you mind, as with other tests, I will review every answer that Hawks flags as wrong. So if your answer is equivalent to the correct answer, then I will give you full credit. Okay, next one. It's asking for first and second derivatives. So for here, you'd use a rule that, so now we're getting to a section on exponential functions, but e to the x is its own derivative. So you'd end up just using a power rule. So 5x to the 4th would give 20x cubed that you see here. And then minus 4 times derivative of e to the x, which is just e to the x. So that's all you would have for that. And then you would just repeat this process for a second derivative. You take a derivative of this. So again, you'd apply power rule to 20x cubed, and that would give you the 60x squared that you see here. And then with e to the x being its own derivative, this term would not change at all, again, when you take its derivative. Okay, so here we're going to give a function on the next page. Okay, there it is. And determine the slope f prime of 5. So we're going to take the derivative and then set x equal to 5. Now, the rule that we're going to use is that when you have the exponential of some function g of x, and you want its derivative, it would be that same function again, e to the g of x, times g prime of x. So you have to remember to multiply by the derivative of the exponent. So maybe put that in parentheses so it's a little more clear. Okay. Now, so if we apply that here, step by step, the derivative will be equal to 5 times the same exponential. Watch the font sizes. It's 1/4 x to the 4th plus 8. That's the exponent. And then you have to take the derivative of that exponent. So when you go to do that, well, a plus 8, that'll contribute nothing because 8 is just a constant. So then this part, by the power rule, you'd have 1/4 times 4, that cancels out, times x cubed. So now the derivative is complete. I'm going to write it this way because it's easier to read. 5x cubed e to the 1/4 x to the 4th plus 8. So then all that's left is to substitute x equal 5 into that. Well, 5 cubed is 125 times 5 is 625. So that's where the 625 comes from. And then if you plug in x equal 5 in here and work out this whole fraction, that's where the 657/4 comes from. So let's write this out. 5 cubed e to the 1/4 5 to the 4th plus 8. And notice in the problem, it didn't say anything about decimal places, so it wasn't an exact expression, like as a fraction. All right, so like I said, 5 times 125 is 625. And then 8 is rewritten as 32/4. So that's where the 657/4 comes from. It's by using a common denominator. Okay, another absolute max min problem. Here's your function, here's your interval. So you need to consider the two endpoints, -5 and 1. And then any points where the derivative is 0, as long as they fall within this interval. So for this, you're going to need the product rule. So we're going to have the exponential times the derivative of the functions that's multiplying it. So that'd be -10x plus minus 5x squared times the derivative of e to the 0.8x. Well, that would be itself times the derivative of the exponent, which is 0.8. Okay. So now if we clean up the constants, so we have -10x e to the 0.8x, and then minus 5 times 0.8, that's going to be 4 x squared e to the 0.8x. Okay. All right. Now, we need to set this equal to 0. Now, in doing that, it's easier to figure out where it's equal to 0 if we factor out whatever we can. Notice there's a e to the 0.8x that can be factored out, and then there's an x in each term that can be factored out also. So if we go ahead and do that, also can factor out a -2 x e to the 0.8x. So what's left? Well, from this term, the only thing left will be a 5. And then the only thing left from this term will be a -2x. So now we set this equal to 0 and define any critical points. Now, e to the 0.8x, the exponential function, no matter what the exponent is, it's never 0. So you can forget about that. And then here we have -2x, so that'll be 0 when x is 0. And then we see where this is 0. So that would be x equal to 5/2. So critical x is equal to 0 and 2.5. Now, your interval is from -5 to 1. So this second critical value of 2.5, we ignore it because it's not within this interval. All right, so because of the interval that we have, we will only consider x equals 0 as a candidate for a max and min. So now our candidates so x is equal to -5 because that's an endpoint, and then 0 because it's a critical value, and then 1 because it's an endpoint. So then what you would do is substitute all of these x values into the function, the original function, and then smallest value is min, largest value is max. So once that's done, we see that x equals 1, that generated the smallest value, so -11, and then the so turn out all the values were negative except when x equals 0, we get 0. So that turns out to be the absolute maximum, just because the function is negative everywhere else in this interval. Excuse me. Okay. Here's demand for a function, so that would indicate the price at which it would sell. And we're trying to maximize revenue. So revenue, which I'll call R of x, is x times the demand function. So that would be 140x e to the -0.05x. So this is the function we want to find the maximum of. So for that, we need to take the derivative, but that's going to require the product rule. So that would be the exponential times the derivative of 140x, which is 140, and then plus 140x times the derivative of the exponential, which would be itself, times the derivative of the exponent, which is -0.05. So now, if we clean up all of the constants, uh, 140 times 0.05 is 7. So we'd have -7 e to the 0.05x. All right, so this is our derivative. So then we set it equal to 0. So we have 140x e to the minus 0.05x minus 7, same exponential. Now, like in the last problem, we factor out whatever you can. We can factor out 7, and we can factor out the exponential. So what's left? 140 divided by 7, that is 20, and then we have x. Sorry. Hold on. I have a typo here. Yeah, okay. This x should not be here. It should be here. I apologize. Let me backtrack a little bit. Here is the derivative after dealing with the product rule. Notice I have 140x times minus 0.05. So 140 times 0.05 is 7. So it should be 7x. Here, the first term, we have 140 by itself, no x. So somehow, in going from this step to this step, I accidentally moved the x from the first goof there. All right, so this is the derivative. So let me fix that over here too. All right, so when we factor 7 times in the exponential out of this term, all that's left is 140 divided by 7, which is 20. And then here, I factor out 7 in the exponential. The only thing left is an x. So now we see where each factor of its derivative could be 0. Well, the exponential is never 0. So the only part that can be 0 is the 20 minus x. So x equals 20 is a one and only critical value, and that ends up being the answer. That's because it wants an x value, because x is number of units, and that's what it's asking for. The number of units sold that happens to give maximum revenue. So in this problem, we don't actually care what the maximum revenue actually is, just how many units will give the maximum. Questions on that one? Okay, the other step of a problem, now that we know that revenue is maximized at 20 units, what's the price per unit that would give maximum revenue? So for that, we go back to the demand function, d of x, we substitute x equals 20 into there. So the price comes from demand function d of 20. So that would be 140 e to the minus 0.5 times 20, sorry, 0.05. So that would be 140 times e to the minus 1. And when rounded to the nearest cent, that's $51.50. All right. Last problem for this first half I will do today. Just finding a derivative of this function. For this, the product rule is needed. So that would give e to the x times the derivative of minus 9x cubed. So that'd be minus 27x squared plus minus 9x cubed times the derivative of e to the x, but that's just e to the x, its own derivative. So then when we clean it up, we get minus 27x squared e to the x, and then minus 9x cubed e to the x. Okay. So now we've gone through 10 of the 20 problems. Does anyone have questions about the 10 that I've shown you? Okay. I will stop recording at this point, and I'll be back with the other half on Thursday.